Hello, everybody, and thank you for joining us today for Vertica Unify 2021. This breakout session is entitled Machine Learning with Python and Vertica using VerticaPy. I'm Joy King, and I lead Vertica product and go-to-market strategy. I'll be your host for this breakout session. Joining me is Badr Ouali, one of Vertica's most passionate lead data scientists. But before we begin, I encourage you to submit questions during the virtual session. You don't have to wait. Just enter your question into the Q&A box on the right-hand side of the screen. There will be a Q&A session at the end of the presentation. We'll answer as many questions as possible during that time. Any questions that we don't address, we'll do our best to answer offline. Alternatively, visit the Virtual Developer Lounge to ask additional questions and continue the conversation with our engineers and product experts after the session. And yes, this virtual session is being recorded and will be available to view on demand this week. We'll send you a notification as soon as it's ready. Please stick around to get the code to gain points to participate in our Analyze to Win competition and win prizes. Now, let's get started. Over to you, Badr.
Thank you very much, Joy. During this amazing event, we covered many interesting topics. And now we will cover one you're probably waiting for. Machine learning with Python and Vertica using VerticaPy. My name is Badr. I'm a lead data scientist at Vertica and the creator of VerticaPy. I'm so glad to present you today some of the key features we have and why using in-database technologies to solve complex use cases. You will see how to switch from reactive to proactive and why our technology is unique. First, let's look at the journey to best in analytics. When looking at the analytics best practices, we usually strike a problem using two main metrics, the value and the capability. For years, many companies store data knowing that one day they will be able to use analytics at the top of them. Many still have not the right tools to pre-process their data correctly, and they just query the database. We all face the point where we just query the entire dataset using select star from table, and then faced in-memory problems. With a lot of work, we can totally automate this exhaustive process and reach a point where we can use very basic aggregations to run our business. We can monitor and alert using rules and thresholds. Most of the companies can reach this stage after a lot of work. But is it enough? Maybe for a short period. However, being reactive can lead to many complex problems. Maintenance is high and we need to have experts on site to take most of the decisions. Indeed, rules and thresholds are inefficient when the decision to take is not usual. It will most of the time solve very easy use cases. But what about the others? Why not allocating more resources and do a small effort to switch from reactive to proactive? When using machine learning and advanced analytics, we can then discover patterns we never thought about, and we can do predictions based on our data. It is not the ultimate goal, where we can dynamically run our business, and where machine learning is used to create automatically models. No need to reach this stage to bring our business to another level. Switching from reactive to proactive is not so difficult when we have good tools. We can, with a very small effort, use machine learning and advanced analytical functions to take better decisions. This step is what I expect from any company which is thinking about the future. As all the basic analytics are already implemented in the system, this step can be done easily by bringing the good resources. You can gain value without putting too much effort. To understand why, we need to look at the different data science challenges. In any data science project, we need to clearly understand what we want to achieve. There are many problematics. Predictive maintenance, churn, risks. You can imagine that with the same dataset, you may have an infinite number of use cases. Why predicting a specific variable instead of another? Or a variable which is a combination of the others? We need to be clear and to set the correct problematic, otherwise we may go to a wrong direction. What we need is to improve the business. No need to try to find how to solve a very complex problematic. A successful data science project is the one that will go step by step to the optimal solution. Be clear and precise. It is important to choose the right ETL to ingest the data needed for the project. We may have a lot of data we ingested for years, but are they the one we need to solve our problematic? This part of the process is really important. Without it, we cannot continue to the next step. To see if the problem is solvable, we need to explore the data and check the data quality. If we found that it is not sufficient, we may ask data engineer to see if they can ingest whatever is needed. Otherwise, we can do one of the most exhaustive steps of the process. Data preparation can represent most of the time of the cycle. In most of the projects, it can represent more than 90% of the pipeline. If we think about it, it is the part where we need to discover the relevant features which will help us to drive the decisions. If, for example, I need to predict customers' churn, I will have to build features that are important for the customers. Did he call the call center? Did we find a solution to their issues? Did they use their roaming package? When the variable is easy to interpret, we can then predict and take actions like calling the customer, giving him some discounts, etc. If we found we don't have enough data to solve the problem, we may reformulate the problematic. If we found it is good enough, we have to implement a model and use machine learning. Machine learning is not magic. It will just learn the data we have. Each use case has its own specificity. Not all the use cases having the same problematic can be solved the same way. Besides, machine learning is a data-driven solution. If every man in our dataset are churning, it will predict for any new record of a man that he will churn. We need to be careful when doing the model evaluation and ask ourselves the good questions. Choose the correct metric and always see if it works for our use case. At the end, we try to improve our business, even for a bit. If the model does not satisfy our expectations, we may come back and ask ourselves more questions. Otherwise, it is needed to build dashboards to drive a business. Everyone has not coding skills. If you have employees and they have to take actions according to some specific situations, you want them to understand what's going on. I really insist on model explainability to build nice dashboards. We need to understand what we do to not provide some kind of black box from which we take decisions. As I said, models are data-driven and they may not be optimal if the data are not good enough. When all the process works fine, we need to deploy our work and maintain it. It is important that our solution stays through time. That's why we may reach a point where we could ask ourselves, is it good enough? If not, we may again reformulate our problematic. Otherwise, we can end the project and start another. We can see the need of different experts, business analysts, data scientists, and data engineers. Projects can then be hard to manage because at each step, one of the experts may be locked and he may have to wait to continue his tasks. Each phase can involve different tools and it can become quickly hard to maintain. The data science journey is most of the time really complicated. Any actor of a data science cycle will probably connect to a database using his credentials. Most of the time, ODBC or JDBC drivers are enough. He will extract the information he needs, do some joins, and he may pre-process the data a bit in order to build his sample that he will load using in-memory technologies like Python, R, or Spark. He will do a lot of pre-processing and he will probably build a model. It will take time and may lead to overfitting. But the work is not done yet. The hardest phase will be to put his work into production. Indeed, he will have to translate his work to automate the data science pipeline, where he can face many challenges for deployment, maintenance, efficiency, and even security, where the data movements across the systems can make the process very complicated. We can see that the cycle we showed before can become very complex, leading to exhaustive projects. Many companies give up because of this complexity. Besides, even if he succeeds putting the model into production, it may be incorrect because of downsampling. And we know that downsampling may lead to very brutal approximations. We may miss some patterns, or even worse, we may not predict correctly what we are expecting. Whenever we can, we should work with large datasets. Some of you may say that a good sample may be good enough. But what is a good sample? When losing information, it is then hard to detect anomalies, which are by definition outliers. It will be hard to compute our moving windows or advanced analytical functions like sessionization. Our interpolations might be biased as well as the missing values imputations. Just imagine erasing the data points having the patterns you're searching for, or putting bias in the model. We saw it many times in presidential elections where we try to guess who will win. Most of the time we are wrong because we consider a small subset who accepted to answer to the interview. When having enough quality, we should consider using all the data we have. Downsampling is not the only problem. When using legacy systems and trying to use in-memory solutions, most of the time we need more hardware. Reaching a small dataset of hundreds of gigabytes is enough to make it hard to manage in memory. We will need more hardware, more maintenance, more expertise. Something easy can become challenging. Of course, in-memory computations are very expensive and can easily reach their limits. But pain points will be the development and deployment. How to deploy your work? Will you create very basic models with coefficients that you will copy-paste for deployment? Or write endless case-when statements? And even if you succeeded deploying your work, how will you maintain it? How the other team members will deploy it? How many actors do we need in this process? Trends are not necessarily what should be done. We need a solution where everything can happen where the data resides. A solution that will bring the analytics to the next level. A solution that will bring the logic to the data and not the opposite. A solution that can give an answer to 3 main points. Working with all the data. Avoiding downsampling, making it possible to gain time on the pre-processing phase. A distributed machine learning system to achieve a proper speed at a reasonable cost. Moreover, it would not be easy nor efficient to move big data around. Hence, it is preferred to bring training and scoring of machine learning model close to the data. This solution exists, and that's what we imagined 5 years ago. Vertica machine learning is the first real in-database machine learning. It was made by data science experts for all the data science community. Vertica machine learning allows to use pipeline mechanisms to smoothly train models and manage them. All the computations are happening in database, and we don't have to think about data movement across the systems. Data engineers, analysts, and scientists can work together in a unified place. They don't need to learn difficult programming languages to work with big volume of data. They can work in SQL and Python. We are helping hundreds of businesses to take better decisions by simplifying all the possible painful steps. When customers are asking how much they must pay for it, they are a little bit surprised that we provide it without any added costs. When you have Vertica, you have in-database machine learning. You can improve your decisions now and with a very easy mechanism. But what is different from other databases in terms of performance? It's quite simple. We are providing a freshly new implementation in C++ of many well-known algorithms like extreme gradient boosting or random forest. We are not using third-party tools in the middle. We have a dedicated team to improve a project to give to our customers the key features they need to drive their business. In-database machine learning to eliminate the data transfer across the systems, making easy collaboration between all the actors of the project. It is secure and we know the data provenance. No need to think about how to track what is going on outside our environment, how the data were used, where were they used. You are working in a unified system, with an entire model management system where all models are stored and where it is possible to use them the same way we are using the other relations. It can support concurrent users and sessions. You can isolate resources for multiple user sessions. The memory usage for machine learning is configurable and there is a natural segmentation of users and privileges. Vertica machine learning is highly scalable. It leverages MPP infrastructure and scale-out architecture to bring the analytics to the next level. We have our own unique implementation to make the training and scoring phases always faster. And as you are working in one unified analytical environment, you have no maintenance costs of a separate system. You are in an environment where data science project can be done end-to-end. Managing models becomes so easy. In Vertica, we can work with models the same way we work with any relation. You can select them, alter them, ground usage and privileges, look at the statistics or the attributes, and of course drop them. Many things are possible to track the models, retrain them, look at different metrics. Model explainability is also really important, and in Vertica it is possible to get many features importance information and to get a real model explainability. You are seeing SQL code, but the same can be done in Python. We will see how later. You can notice the advantages of having this kind of implementation where it is possible to plug any software having ODBC JDBC connection to Vertica and write the query we need for our data visualization. Everything becomes easy. Vertica supports the entire data science process end-to-end, from data ingestion with many parsers for CSV, JSON, Avro, or even shapefiles for geospatial use cases. Everything needed to explore and analyze our data. Outlier detection, sessionization, correlation, pattern matching. We even extended joins to time series and geospatial, allowing to compute intersections between polygons and data points, to combine it with time series analytics, slicing and interpolating timestamps. To preprocess the data, there are functions to normalize the data and to impute missing values. And when we need to build models, we provide one of the key features, which is Vertica in-database machine learning. Many algorithms are available like extreme gradient boosting, random forest, P16 k-means, and much more. All the functions to evaluate the model are available like the ROC curve, R-squared, grid search, etc. You are using analytics in one place and centralizing all your work. If needed, you can even bring your own code using user-defined functions. Our integration is quite complete and it is possible to do machine learning using different strategies. Indeed, in Vertica there are many ways to solve data science challenges. The native way with SQL, the Pythonic way with VerticaPy. There is the possibility of bringing customized code and to run it across the systems using user-defined functions. But it is possible to bring TensorFlow models for in-database scoring or to import and export PMML model for more flexibility. We can see that not only Vertica is providing in-database machine learning, it gives us the possibility to bring outside models in and to bring the built-in models out. There is no lock-in. We help our customers to drive their business the way they want. It is important that if they have some restrictions, we'll help them bring in their work where they need to do the scoring. This flexibility is very important in data science. We may face challenges because of the different softwares used, our team expertise, or other restrictions. Vertica is not just a simple data warehouse. It is an entire data science platform where any user can connect to and use in-database machine learning built to scale. The user can also build customized Lambda functions called user-defined functions. User-defined functions are functions customized by you in one of the 4 available programming languages: C++, Python, Java, or R. Vertica provides everything needed to switch from reactive to proactive, giving you the flexibility you need to centralize your work into a unified platform. Vertica is an advanced analytical platform with 4 main pillars: high performance, an open architecture which can integrate with many other technologies, a unique management system where we can work with models with the same way we work with tables or views, and an ease of use. Vertica ML is easy to deploy and to integrate. That's why we decided to create its Python integration, to always bring to our customer what they need to make their data science project successful. The idea behind VerticaPy is simple. Vertica has many advantages, making it an extremely powerful system, a standard SQL with many built-in functions made to simplify the entire data science pipeline, high security, the data stays in Vertica, in-database machine learning made from scratch in C++ and built to scale, integration with many different technologies to give to the users the flexibility they need. On the other hand, Python is a high level of abstraction programming language. The flexibility and the easiness are Python key components. Jupyter is the de facto interface for the creation of data science notebooks. The rendering capabilities are huge with APIs like Harcharts and Matplotlib. Python offers the possibility of creating attributes and methods to automate the data science lab. What about combining the best of both worlds? For you, we created VerticaPy, taking Vertica advantages and using a pipeline mechanism to push all the computations to Vertica. It is using Python front-end with new generation objects built to scale. Indeed, all the heavy computations are pushed to Vertica. This open source project has everything you need to contribute. Unit tests, GitHub Actions with Node to test your implementation, hundreds of functionalities to make any data science project successful. VerticaPy was designed by data scientists for data scientists. It allows to create the data frame and the models, which are Python objects. They use ODBC, JDBC or native connection to connect to Vertica. Vertica can compute all the aggregations and send back the result. It can be an aggregated table or information around the model. VerticaPy will never load the entire dataset in memory except if a user implicitly asks for it. The data frame can be seen as an updated view which is not stored in database. A function is available to store the final relation if needed. Every computation is pushed to Vertica. The data frame can be used to do data exploration or data preparation. It works with lazy computations and pushes the SQL pipeline only when it is needed. The models have high level of abstraction functions which can be used to do their evaluation and to explain them. Remember, the integration with Jupyter is quite complete. All the computations are happening in Vertica, where we can track the data and get high security. And of course, as it is open source and the community is really active, you can develop quickly what is needed to solve a business use case. To understand the API, let's use the following example. We want to describe a dataset and compute all the descriptive statistics. We can use our DSN name to connect and use the describe method. It is a bit similar to the pandas.describe method, but here, VerticaPy will send the query to Vertica. You can see the built-in function which allows to compute the descriptive statistics, summarize numCal. This built-in function is much faster and scalable than selecting all the aggregations like the average, the median, the quantiles. Vertica can compute all the aggregations at once and send back the result. We are using in-database functionalities to make the computations much faster. And if a function is missing, VerticaPy uses the Vertica Python SDK to build user-defined functions. You may have a specific Python code that you want to bring. VerticaPy can generate user-defined scalar functions. Vertica will create a copy of a file in all the nodes. It is needed to be able to independently invoke the function. Vertica can then share blocks of data depending on how they are stored. Do the computation, making the process faster and easier to maintain. And if you want to use other programming languages, Vertica offers multiple ways of bringing outside code. It can be R, Java, or C++. But let's go back to the Python user-defined function and take the following example. We want to bring the isClose function from the math package. This function is taking as argument two floats and it returns a boolean. It has also an optional parameter which is represented by a float and named the absolute tolerance. Using VerticaPy user-defined function, we can generate the code to create the function. Vertica can distribute the execution, and we can invoke it using the VerticaPy SQL magic option. It is then easy to use and easy to maintain. VerticaPy is a complete package gathering in-database machine learning to scale, statistical tests and tools, an entire object for advanced data preparation. With more than 600 advanced functionalities and more than 80 automated charts available, VerticaPy can be used to deal with big data. No need to bring the data out, you can bring the logic to the data. If we want to have the same functions in ordinary Python, we will need to combine 3 different packages: scikit-learn, pandas, and stats models. Data preparation and exploration are much easier in VerticaPy. If you already face the pandas group by object, you might know the difficulty of computing aggregations using pandas. As VerticaPy is using Vertica SQL backend, the syntax of many functions are easy and they are already pushed to the core engine. We will not have all the scikit-learn algorithms because many of them are not built to scale. They have a too high complexity for making it work on big data. But any scalable algorithm will be available in VerticaPy. In all cases, it is still possible to bring outside models in Vertica, so we always have the flexibility of the process. VerticaPy is a complete package, easy to use and easy to learn. If we compare VerticaPy to the 3 APIs Pandas, scikit-learn and stat models, we can see huge similarity in the use. We can read CSV using the readCSV function. VerticaPy will use flex tables to identify and parse the type. On the contrary, Pandas readCSV will load the data in memory. We can import and create a model. In VerticaPy, models have names. They are stored in Vertica and they can be used and deployed later if needed. We can feed the model and compute the R-squared. You can notice that we obtain approximately the same score. The logic stays the same, but one of the model is trained using parallelization of a Vertica MPP architecture, whereas the scikit-learn model is trained in memory. Besides, with VerticaPy we are using one package which is maintained. On the other side, we have to use 3 different packages. You will have much more functionalities which are easier to call and easier to maintain. We can compute the features importance. In VerticaPy, it is with one method. Scikit-learn, we will have to manually do it. VerticaPy, many high level of abstractions functions are there to simplify the process. You got panels of statistical functions that are evolving through time to give you a Pythonic experience, but where everything is pushed in database. Besides, when you want to switch to SQL, it is easy. You can load the SQL Magic extension. Play with SQL. Compute advanced analytical features with Vertica built-in functionalities. Export your query to a vdata frame. To draw many charts. Load the vcharts extension. To draw responsive graphics. In VerticaPy, it is easy to switch from Python to SQL or the opposite. We try to combine the best of both programming languages, giving you the flexibility of choice. When working with Python, VerticaPy is using SQL code generation, that you can use to maintain your system. You can see that with few lines of code at the left side, we can do our data preparation and we can generate the corresponding SQL query. Imputations can be done using a coalesce statements. Standardizations can be done using the average and the standard deviation. Dropping rows can be done by filtering using the where clause. VData frame will keep in mind users' modification to generate the proper SQL query. That's just magic. VerticaPy can give you all the statistical functions you need to build your data science pipeline. For example, you may need other types of correlations rather than just Pearson. You may want to find monotonic link with Spearman or robust monotonic link with Kendall. Computing correlations between categories with Cramer's V. You have all the statistical tests needed to verify your hypothesis and the stability of your time series model. Brush-Pagan, Goldfeld quant, White's Lagrange multiplier for heteroscedasticity. DK Fuller or Man-Kendall for the trend. Many other tests are available to give you the tools to understand your model. Join different data sources, not only with regular joins but with time series interpolations or special intersections. No need to think about slicing or interpolating your timestamp. With Vertica, you can enrich your data with one line of code. You have also many algorithms which are available built to scale for classification, regression, or unsupervised modeling. If you need some tips, we developed some nice functionalities to automate some part of the data science process. Why not providing a magic quadrant of the machine learning models tested on your data? Use the VerticaPy Delphi package to test the performance and efficiency of different models. It will test many algorithms with different parameters combinations to test which one is maximizing the chosen score. Very good model will be represented by a little bubble at the top right of the quadrant. The size of a bubble being its standard deviation error. VerticaPy Delphi is using advanced auto data preparation to preprocess the data, doing an automatic grid search to find good hyperparameters, and a stepwise backward or forward to find the interesting features. VerticaPy you have many nice functions to help you on your data science journey. Many charts are available, even responsive and dynamic. All models have their own kinds of plots, and you can easily discover from data different patterns. We are every day improving the APIs to give you the most of the data science journey. We listen to our customers and their recommendations to always bring analytics to the next level. I want to thank Information and John Gaetan, who is a project manager for big data and machine learning there. Information is the fintech of the group Crédit Mutuel, a bank in France, and this is what they said. Taking advantage of in-database machine learning, we now support use cases we could not handle before. We are working together on their success because the success of our customers is ours. When we do data science, we need to be able to easily do all the computation in database. We need a scalable platform where we can deploy our work. Rolando, a senior business analyst at Axtel, a well-known telco operator in South America, tells us the simplicity behind Vertica ML. Vertica is a data science-ready database. You don't need to be or have a data scientist. Just use the out-of-the-box ML algorithms. Feed data and in a matter of seconds you will see insights, knowledge, predictions and more. You only have to know your business and let Vertica do the job. Thank you, Rolando, for this feedback. We want to really fill this gap between expectations and reality, to allow to all data scientists to create their pipelines easily in one unified platform. Before switching to Q&A, I want you to take some seconds and join us in this amazing journey. We even started video to help you to understand how to use the API and to give you some tips for many different use cases, credit card fraud, attribution models, churn and more. Before switching to Q&A, we need to see VerticaPy into action using a short demo. We can connect using our credentials. Load the SQL Magic extension. We can write direct SQL queries in Jupyter notebooks and use Vertica advanced analytical features. It's also possible to write SQL queries and create responsive charts using vCharts extension. You can easily create a vData frame using an existing relation. vData frame can be used with a Pythonic syntax. You can use magic operators to filter the data. vData frames are pushing all the computations to Vertica. You can turn on the SQL and look at the SQL generation behind each function. Core method will use the core matrix function of Vertica. It represents Pearson coefficients. If we need Spearman, we will need to compute the Pearson coefficients of the ranks. The same applies to describe where we will invoke the summarize num count function. You can also look at the SQL code generation when building models. Or computing the AUC. Vertica has all the built-in functions to simplify the data science process. Many functions for data exploration are available and can quickly give insights. Negative bars, geospatial plots, time series ACF-PACF plots. or even outliers plots on information values. You can pre-process quickly your data. The data frame will keep the information needed to create the relation. And models are easy to evaluate, and many high level of abstraction functions are available, like exporting to graph views to draw trees, rock curve, leaf table, etc. VerticaPy allows to easily integrate with other APIs, like converting to scikit-learn, exporting to Python, or creating a SHAP explainer. You also have AutoML to simplify the process. You can then test many models to find the champion challenger. Thank you again for listening to this presentation. It is time for you to ask questions. Do not hesitate, we are here for that.
Thank you so much for your presentation. Now we're ready for Q&A.
Okay, as usual, your passion was very clear, exactly what we expect. So questions are coming in, Badr, and we have about 10 minutes or so to take them. So the first one has the greatest number of votes from the audience. Wants to hear, what is your perspective? What are the facts on Vertica machine learning as compared to other in-database machine learning technologies like Oracle or Amazon SageMaker, for example?
So first, we have to consider that we have our own implementation of the algorithms. That's not the case of a lot of other products. Because if, for example, I will not quote them directly, but they will use third-party tools behind the scene in order to do the computations, which means that they are not using scalable training. What they are doing is pushing computation to another technologies, and specifically most of the time it's in-memory technology. Then they create the model outside and they bring it in. It's more like an easy way to deploy outside model than an implementation. That's why I think that we should maybe protect the word in database machine learning because it sounds more fair to say that in database machine learning is, let's say, an implementation end-to-end, which is from the database, the training inside the database and deploying there or outside.
So what you're saying really is that there's a big difference between connected to machine learning and in-database machine learning.
Exactly. It's more like, just imagine that because we always say that, you know, it's a waste of time or of recreating something from scratch. You can use what is available in the market in order to do your implementation. I'm always hearing you will not reinvent the wheel. That's something that I'm, hearing every day. But the thing is, okay, I can use something from outside, but after, will it be as efficient than creating our own implementation with the everything we got in the past few years? Because we know that data science is evolving quite fast. So just imagine what can happen in 5 years. So basically re-implementing something and creating this type of implementation in C++, it's like a revolution, I can say directly, comparing just to push some computation outside and just bringing a model. By the way, we are also doing it if you want to bring some outside model in Vertica. It's totally possible. And maybe there will be another question around it. So I'll leave it now.
You're absolutely right. So there's actually two questions related to that. The one that has the most interest from the audience is this one. It says, first, how do you import TensorFlow models in Vertica? And part of the same question, but it's really a separate question, Badr, is it possible to import Python pickles? Maybe you should explain Python pickles to everybody just in case too.
Okay, so I will first start with TensorFlow. Recently, like 1 year ago, we started this integration with TensorFlow in order to bring outside model, so model created in TensorFlow, directly in Vertica. So basically, in TensorFlow, you have this process where you can export your model using what we call the frozen graph. And this format can be read in Vertica, and we can scale the computation. So be careful. It's more like you train outside and you bring it in. But we don't call it in database machine learning. We just call it in integration with TensorFlow. That's totally different. We bring this model in. Then there is a common way, because you know when you are a data scientist, most of the time, and if you are in a consultancy company, you will work in different projects with different customers. So most of the time you will master different tools. And one common way of playing with models in Python is to create what we call pickle. Pickle is a binary format that will, let's say, compress your model inside this file. Like this, you can export it. But it was created not only for models, for many other operations, but we use it as some kind of model management system because we don't have one. So basically, we export the file and we bring them elsewhere in order to, deploy it elsewhere. That's a way of doing it. The question now, can we bring it inside Vertica? And the answer is yes, of course. You can create a user-defined function, and then, of course, you can unpickle, and then create a functions to unpickle your file. We didn't create some kind of very tight integration, but with the flexibility of user-defined functions, you can still save your model, create your dependencies, and maybe you want to load some kind of model in Vertica to do the scoring with another API. That's totally your choice. You can still do it.
Okay, so that's really clear. Now, here's another question about importing models. Can I import sklearn models to Vertica?
So it follows the same logic. So there will be multiple ways of bringing a scikit-learn model in Vertica. Of course, you will have to have when you create your user-defined functions, you have a statement which is dependencies in order to indicate all the dependencies. So you will indicate, of course, that it is scikit-learn dependent. Then what you can do, of course, two ways. One way is you just copy paste your code, and then you copy the coefficient. You just how can I say? You just create the different variables that will allow you to do the computations. It's very hard. Or you can play with the pickle, load the pickle, and do the scoring. It's feasible, but you will have, of course, to implement it, and it will differ for each functions, because you can understand that in scikit-learn, the different methods of the different models can work, let's say, differently. For example, predict will predict some probabilities, predict will predict the output, predict cluster will predict the cluster. So you will have to adapt. But if you are, let's say, working with Python with at least 2 years and you have some experience, it's no headache. It will be easy.
Okay. So now the next couple of questions are a little bit related to, not a little, a lot related to performance. And I think this will be something that will make you smile. So the first question is, do we have any benchmarks comparing Vertica machine learning to other technologies like Spark, for example? Thinking about
yes,
underlying infrastructure, concurrency, things like that.
Yes, we do. We compared our performance with Spark. First thing that I want to mention is that we have implemented these algorithms, but we are following some scientific paper. So if someone is following the same paper, he will get the same result. So it's not a question of result, but performance. Because, of course, if I use a linear regression in Vertica, I can expect the same result than a linear regression in other platform like scikit-learn. But we are bringing scalability, and that's what we are bringing. And we are bringing a solution to these in-memory computations. Because in Spark, okay, you are in memory, you will have to create multiple nodes, load this data set in memory, do your computation, and then think about how you can deploy your work in order, I don't know, if you want to create dashboard, etc. So we compared apple to apple, which means we just compare the performance. We didn't compare data movement, all these things, because if you take it, then we are far away, let's say, in the race. But apple to apple, we can see that even if we are working on disk, whereas Spark is 100% in memory, we can reach faster performance for at least 80% of our algorithms compared to the one on Spark. And we have some benchmark, of course, against Spark.
Okay, so that can all be made available after the event for anybody that's interested. Now, another question that is really based on performance and in some cases scale that has a lot of votes as well is VerticaPy passes the workload to the database. What are the limitations on how much load it's allowed to place on the database?
So of course, when you are using tools, you need to know at least a bit how to use them. Of course, we are pushing computation to Vertica, but after, if just imagine that you are pushing too much, of course, you can create some problems. And that's why, you have to manage the concurrency in your system, and you have all this infrastructure. It's going beyond VerticaPy. It's going through Vertica itself. So basically, you can see VerticaPy just like a layer where we generate SQL. Behind the scene, of course, you have your own data engineers that will, for example, grant some usage, privileges, try to see which resources to provide. You have all this mechanism that is already normally implemented in your environment when you use VerticaPy. So just see VerticaPy as this layer, this Python integration, this new abstraction, new high level of abstraction language just above Vertica. But for this, of course, for more details about how Vertica stores the data, how Vertica process the security in Vertica, it will be for another session. And we can, of course, you can ask the question, of course, directly by mail or directly in the chat. And of course, we will send back all the information about our amazing database.
Right, and also one other way that people can engage with you and others directly is in the Developers Lounge, where you can have these conversations directly as well. So yeah, don't think this is the end. So another somewhat related performance question. This is a topic that has been discussed within Vertica for a long time. Is there any opportunity or capability to benefit from GPUs, or is this purely based on database compute capability? This is really the GPU question that we have had talked for a long time.
So basically we have, because I understand the trend of GPU, we want computations, it's faster on matrices computations, but this problem is more related, let's say, to deep learning, where most of the computation, let's say, when you do some neural networks, you put many matrices, then of course GPU will work faster than CPU. But it is proved that CPU, in most of the cases, will be faster than a GPU. Of course, this question you can ask yourself, but let's say you're using TensorFlow integration because you like GPU, you like deep learning. You're building your environment outside, and of course, you are not locked of using a GPU outside and then bring your work in Vertica. But now we are using, as you already know, CPU. But if you want more information, again, I think we are reaching the end. Come to the Developer Lounge, and we will try to answer to all these questions.
And related to that, is there a minimum in-memory requirement for optimal performance? That gets very much to specific workloads or projects. I think we'll get your perspective on that.
Yeah. So all these kind of questions, like really, let's say, very technical, you will see that Vertica is a really mature product. So we got many problematics around these 20 years, 16 years. So we got all these different problematics, and each time, in each release, we try to cover most of it. We try to bring, that's our motto, the analytics to the next level. And I can say that if you have more questions related to this topic, go and come to the Developer Lounge. I'll be available tomorrow.
Okay, and I also do want to tell everybody that Badr is personally responsible for the vast majority of the content on vertica.com/VerticaPy, and you will find a lot of information about VerticaPy there, as you saw that URL throughout the presentation. So I think we are just about to wrap up. And Badr, do you want to make any final comments, especially about the power of not only, as Colin said yesterday in the keynote, being able to run, train, score the model, replicate the model, prove that people can trust the outcome? That's a major advantage of not having to downsample, I think.
Yes, yes, and we can close it this way. Just imagine, okay, if you downsample, you will always rely on this in this sample, and you will never generalize. What we are trying to do is to give you the tools that you need in order to not think about downsampling. Downsampling is a solution when you have just this solution, when you just have a sample of data. Why not using everything you have? And thank you very much for assisting to this presentation, and I hope you enjoyed it and you are enjoying, of course, the entire event.
Thank you very much. It was a pleasure. Everybody should join the Developer Lounge, and also make sure that you take advantage of all the other URLs and information that Badr shared. So thank you. And now we will close this up by sharing a very important piece of data, which is the code for Analyze to Win. And remember, with this code, when you enter it, you not only earn points, earn prizes, but you make a difference in a dog's life. So today, for this session, the code is Corgi, a special honor to my daughters, Albert the Corgi. So it's Corgi, C-O-R-G-I. Please do enter the code. Now also, you will see a short video from one of our platinum sponsors, Pure Storage. And I strongly encourage you to drop by the Pure Storage Platinum Sponsor Showcase. You'll be able to see live technology of how Pure Storage and Vertica in Eon mode really do bring cloud innovation and the separation of compute and storage down to on-premises data centers. So with that, thank you very much. Enter Corgi, and here's Pure.
Pure Storage FlashBlade, the leading unified fast file and object platform, or UFFO, is built to address the needs of modern, unstructured data and consolidate workloads on a single platform. FlashBlade delivers performance, simplicity, and scalability to power the most demanding workloads while enabling modern analytics and delivering unmatched data protection, rapid restore, and ransomware protection, all with less downtime thanks to non-disruptive upgrades.